Hello, this is Scholar Strive doing some math today, and number 2 will be looking at sequences and series. A sequence is a function whose domain, otherwise known as your inputs, is a set of consecutive integers, usually starting with 1. So, for example, if we look at this number 3 here, we have a sequence here, 1, 4, 9, 16, 25. Its domain would be 1, 2, 3, 4. And the range is what the numbers that we get out. That would be the 1, 4, 9, 16, 25. The terms of a sequence is basically the output. So 1 is a term, 4 is a term, 9 is a term, 16 is a term, and 25 is a term of the sequence. So once again, we have a sequence domain. If we plug in 1 into this thing, the sequence, we'll get 1. If we plug in 2, we get 4. We plug in 3, we get 9, 4, 16, 5, 25. Infinite sequence is just... oh, wait, I forgot. Finite sequence, it has a limited number of terms it ends. An infinite sequence goes on forever. So this would be 36, 49, keeps on going forever and ever and ever. An explicit rule gives a sub n as a function of the term's position number in the sequence. And then here's some examples on the next page. So this is our explicit rule here. So if I want to know a certain position in the sequence, I would just plug, like if I wanted to know the second position, I would plug in n equals 2 into this equation. That will give me a number. So our problem here is write the first 6 terms of the sequences. So we're just plugging in 1 through 6 into our equation to get our 6 terms of the sequence. So if I plug in 1, I'll get negative 2 to the 1 minus 1, which is negative 2 to the 0th power, and anything to the 0th power is 1. If I plug in 2, I'll get negative 2 to the 2 minus 1. That'll make negative 2 to the first. Negative 2 to the first is negative 2. If I plug in 3, I'll get negative 2 to the 3 minus 1, which is negative 2 squared, which is positive 4. So here's my sequence. 1, negative 2, 4. If I plug in 4 into the equation, I'll get negative 8. Plug in 5, I'll get negative 16. Plug in 6, I'll get positive 32. So that would be my answer here. Okay, part B. F of 1 equals 1 over 1 plus 1, which is 1/2. If I plug in 2, I'll get 2 over 2 plus 1, which is 2 over 3. F of 3 equals 3 over 4. And then f of 4 equals 4 over 5. And then we got 5 over 6 and 6 over 7. All right, part A, or try it 2. So let's go backwards. So this time, so last time we found our sequence, or at least putting in some terms. We didn't go through all the terms because that would be infinite. But here they want us to write a rule. So we need to remember that if we plug in 1, we get -1. If we plug in 2, we get -8. Plug in 3, we get -27. If we plug in 4, we get -64. So we need to figure out some sort of rule. So let's see what's going on. If we notice, 8 is the cube root of 2. So you could say this is -2 cubed. -27 is -3 cubed. And -64 is -4 cubed. So everything is just... Well, first it's being negative. So if I took 1 and I end up getting -1, first I made it negative and then I cubed it. So my rule for this one is negative n cubed. Part B, so if I plug in 1, I get 3. Plug in 2, I get 8. Plug in 3, I get 15. Plug in 4, I get 24. So what's going on here? Now it's okay if you don't notice these patterns right away because we're going to be practicing a lot of these. But what's going on is, well, let's see, how do we get from 1 to 3? Well, I multiplied by 3. How do we get from 2 to 8? 2 times 4. 3 to 15, 3 times 5. 4 times 6. So do you see a pattern here? I'm multiplying the next number. It'd be 1 times 3, 2 times 4, 3 times 5, 4 times 6. The next one would be 5 times 7. So I'm just adding 1 to each of those. So this sequence is the same thing as n time, or whoa, what did I put here? A sub n equals n times n plus 2. And once again, if you don't recognize these patterns, we're going to practice a lot more of these. We'll be able to see how these patterns work, how to find them, and be able to do these a little bit easier. Write a rule for the sequence describing the total number of blocks at each iteration, then determine how many blocks will be in A25. Okay. So let's take a look at this. Oh. So diagram 1, we start off with 3 blocks. And then we have 5 blocks, and then 7 blocks. Now what's going on here is it looks like we're adding, so we have the corner block, and then we add 2. Here we have that corner block, and then we add 4. And then once again we add 6, 3 on each side of the corner block. So the first, we added 1 piece to the corner, then we added another piece, and then we added another piece. So it looks like we're adding another 2 each time. So our rule for this would be 2 times n, right? And then we just add 1. Because this is just 2 times 1. This is 2 times 2. 2 times 3. Because we're just adding another 2 blocks every next diagram. And you know, diagram 4, we would tack on another block and another block here. That's just adding 2 more. So this is our rule. So to find the 25th diagram, or how many blocks would be in the 25th diagram, we would just plug in 2 times 25 plus 1, which would be 50 plus 1, which is 51 blocks. A series is the sum, and remember sum is addition, of terms in a sequence. So for example, 1 plus 2 plus 3 plus 4. And you have infinite series, 1 plus 2 plus 3 plus 4 plus 5, and finite. When we're using a sum, we use sigma notation. So whenever you see this symbol here, sometimes we'll do this. So that means sigma, and that just means the sum starting at 1 going to an upper limit n, and then our equation or our rule. So let's do some examples using that. So once again, I equals 1. That's basically where our starting point is when we're plugging. This is our starting point for our domain. N is our upper limit, which we stop at. So for example, if we wanted to use this series here, we would say this is starting at 1, like this is my domain here. If I plug in 1, I get 1. If I plug in 2, I get 2. 3, I get 3. 4, I get 4. Well, let's just use a different example. Let's go down here. So here we go. Here's a better example. So if I plug in 1, I get 1. If I plug in 2, I get 4. If I plug in 3, I get 9. 4, 16, 25. Or if I plug in 5, I get 25. So the pattern here is we take our number and then we square it, right? So that's what this is here. This is our rule. And we're starting by plugging in 1 and ending at 5. Okay. So let's do some examples here. Write the series using sigma or summation / sigma notation. Okay, so they're saying 5 plus 10 plus 15. So it looks like our rule is just they're multiples of 5, right? Okay, so my rule is just 5i. Okay, and then we're going to be writing using sigma notation. Okay, we're starting at, this is usually 1. Okay, so we're starting at 1. And we're going to go up to whatever 100 divided by 5 is, that would be 20. So our upper limit is 20. We're stopping at 20. And then our rule is 5i. So this means to starting at when I is 1, all the way up to when I is 20, plug it into this equation here, 5i. And then the sigma notation means to add up each term. Okay. So just once again, this is our upper limit. This is our rule. and then this is our starting point. Alright, let's take a look at this. So part B, it never ends. So when I'm writing my sum here, this is infinity, because it never ends. Okay, so we have that. And usually we start at 1 here. So if I get 1, I get 1/2. If I get 2, I get 4/5. 3, I get 9/10. 4, I get 16/17. So what's going on here? So if I just look at the top numbers, let's see what's going on. If I plug in 1, I get 1. If I plug in 2, I get 4. 3, I get 9. So the top is we take our number and square it. So that's the top. And then how do we get the bottom? Well, that's I squared, but just adding 1. And that's our summation. So here, part C goes on forever and ever. So that means our upper limit's infinity. Start at 1. Now we just need to find our rule. If I plug in 1, I get 6. If I plug in 2, I get 36. So it looks like this is 6 to the 1, 6 squared, 6 cubed. So this is just 6 to the I. Alright. So we do have an upper limit. We're starting at 5, then 6, and 7, then 8, 9, 10, 11, 12. So we're just adding 1 each time, starting from 5. So that is just I plus 4. So I equals 1. And this is 1, 2, 3, 8 would be 4. 9 would be 5, 10 would be 6. So this would be the 8th term, so we're stopping at 8. Okay. Okay, now they want us to find the sum of this series, okay? So they're saying start at j equals 3. Okay. So I'm going to plug in j equals 3, j equals 4, j equals 5, and then our upper limit, j equals 6. Okay, I'm going to plug in all these, then add them all up. Okay. So j equals 3. That gives me 5 minus 2 times 3, which is 5 minus 6, which is negative 1. J equals 4 is 5 minus 2 times 4. So 5 minus 8 is negative 3. If I plug in j equals 5, I'll get negative 5. Plug j equals 6. I'll get 2 times 6, which is 12. 5 minus 12 is negative 7. Okay, now I'm going to add all these. Negative 1 plus negative 3 plus negative 5 plus negative 7 is negative 16. That's my answer. Because it wants us to find the sum, starting when j equals 3, all the way up to j equals 6 of that rule there. Alright, and then we got some special series formulas. So if you ever run into the situation where, well, so this one here is just 1 plus 2, oh no, sorry. So this is this is the series 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus dot dot dot. Goes on forever or whatever. And what this says is the sum starting at 1 going on to whatever you choose will be that number. So if I wanted to add the first 13 numbers, I'll get 13. This next one, this is the sequence 1 plus 2 plus 3 plus 4 plus 5. So just to review, this is the sum of n terms of 1. This is the sum of the first n positive integers. Okay, this is the sum of squares. So this is 1 squared plus 2 squared plus 3 squared, which is 1 plus 4 plus 9 plus 20, or plus 16 plus 25 plus dot dot dot. This is the sum of squares. So, and these equal these formulas here. So, for example, use a formula to find the sum of that one. So that's the middle one here. So this is equal to n times n plus 1 divided by 2. Okay. So n is 25. 25 plus 1 divided by 2. So this is 25 times 26 over 2, which is 325. So these formulas you kind of have to memorize. This first one's, that's pretty easy. If you just want to add 10 ones, you get 10, right? The second one and the third one, you kind of just have to memorize. Hopefully that helped you out. Have a good day.